solving square root and other radical equations. First example, write it down. Solve 2 plus the square root of 3x minus 2 equal to 6. The first step in solving any radical equation is to get the radical by itself. And that's what I did with the red. You subtract 2 from both sides, so you're left with what's inside parentheses here. The square root of 3x minus 2 equals 4. So all I did was subtract 2 to get the radical by itself. Yeah.
Why'd you put the exponent?
That's the next step.
Okay.
So right now you should have what's inside parentheses. Alright? And then that's where the exponent comes in. To get rid of the radical, what's the opposite of square rooting something?
2.
Squaring it. So to get rid of the radical, I have to square the left side, and whatever you do to one side, you have to do it to the other side. So I just square the whole thing. And when I square this side, I'm just left with 3x minus 2. When I square this side, I'm left with 16. Yeah.
After subtracting 2, though?
Yeah, subtracting 2 gave me this.
Is that for, like, all of them? Like, on that side?
Yeah.
Okay.
Alright. So when I square the right, I get 16. And then you solve this like you've solved any equation. Add 2 and divide by 3. Your answer should be 6. And you might want to go ahead and get in the habit, and you'll see why in the later examples of checking your answer. Plug 6 back into the original problem. What's 6 times 3?
18.
18 minus 2?
16.
16. What's the square root of 16?
4.
What's 4 plus 2? 6. So it does work. Alright, so check your answer. Does everybody have that down? Alright, next one. Alright, we've already seen that raising something to a power, we can rewrite it as an exponent, right? So this is the same as the previous example. You just don't see the radical. So the first thing I would do is divide by 2. Get rid of this 2 right here to solve for x. So I get x minus 2 to the 2/3 equals 25. If it makes you feel better, you can rewrite this as the cube root of x minus 2 squared. But I think it's easier just to leave it in exponential form. Alright, so how would you get rid of something to the 2/3 power? What would you have to raise it to?
3 halves.
To the 3 halves, because 2/3 times 3 halves, they cancel each other out. So I just raised the whole problem to the 3 halves power. So on this side, when I raise x minus 2 to the 2/3 to the 3 halves power, you're just left with x minus 2. When I raise 25 to the 3 halves, that's the same thing as taking the square root of 25 and cubing it. What's the square root of 25? 5. What's 5 cubed?
125.
125. And then just add 2 to both sides, you get 127. Okay? Check your answer. What's 127 minus 2?
125.
125. What's the cube root of 125?
5.
5. What's 5 squared?
25.
25 times 2?
50. My
50.
bad.
So it does work. Okay, question on that one before I change the slide. Alright, next example. And this is what I was talking about. Check for extraneous solutions. We've talked about extraneous solutions. Extraneous solutions are solutions you get when you work it out, but they don't work when you plug them back in. That's why you need to check your answers. Probably in this section, when it says check for extraneous solutions, then you're most likely going to have an extraneous solution. Not guaranteed. They both could end up working. Neither one of them could end up working, or one of them could end up working. So in this case, do what we did in the first example. Subtract 5 from both sides. So you end up with the square root of x minus 3 equals x minus 5. To get rid of the radical, you square the whole problem. So on the left side, the radical, or the square root and the square, cancel each other out, so you're left with x minus 3. Now when you square x minus 5, don't just square the x and the 5. What do you have to do?
Multiply by each other.
So you FOIL it. X minus 5 times x minus 5, you FOIL to get x squared minus 10x plus 25. Do not forget to FOIL that. Alright, and then just get it in standard form. Bring the x over, you get minus 11x. Bring the 3 over, you get plus 28. So everybody see how I got this? Any question up to here? And then you, yes,
How'd you get the 11x?
11x, I subtracted this x to get it over here. Minus 10 minus 1 is minus 11.
Okay.
Alright, now we're down to a quadratic, and you've learned many different methods for solving quadratics. You can use the quadratic formula if you want to. It's easiest in this case to just factor it. What two numbers multiply to give you 28 and add to give you negative 11? Negative 7 and negative 4. So there are my two factors. Once you get to your two factors, your two possible answers would be x equals 7 or x equals 4. Check your work. Plug the 7 in. What's 7 minus 3?
4.
4,
4. What's square root of 4?
2,
What's 2 plus 5?
7,
So that one works. Plug the 4 in. What's 4 minus 3?
1,
What's square root of 1?
1,
1 plus 5?
6,
6. 6 does not equal 4. So that one is, x equals 4 is your extraneous solution. So if I just told you to solve it, what's your only solution?
7.
7. Okay? If I told you to list the extraneous solutions, you would say 4. Everybody got that one down? And the last one. Now, in this case, we have two radicals, to the 1/2 power and to the 1/4 power. You need to get one on one side and one on the other side. So I brought the minus 3x plus 4 to the 1/4 over to the other side. So I get 2x plus 1 to the 1/2 equals 3x plus 4 to the 1/4. Now how could I get rid of all fractional exponents? Raise the whole thing to what power?
1,
2/4.
To the 4th. Because when I raise 1/2 to the 4th, what do I get? 2. Half of 4 is 2. Now I don't have a fraction anymore. When I raise 1/4 to the 4th, I get what? 1. So does everybody understand why I raised this whole thing to the 4th power?
Nope.
It has to be your least common multiple of the denominators. So if 2 and 4, what's your least common multiple? 4. Right?
Mm-hmm.
So what would it be if it were 1/2 and 1/6? 6. Okay? 1/2 and 1/7?
7. 1/2.
14. There
Why
you
you
go.
multiply 4?
Okay? Because 2 doesn't go into 7, so we have to multiply the 2 together. Alright, so I'm going to raise this to the 4th, I get 2x plus 1 squared. When I raise this to the 4th, I just left with 3x plus 4. When I square 2x plus 1, you again have to FOIL. You know, with 4x squared plus 4x plus 1. Put it in standard form. Here, I factored. If you don't like factoring, go to the quadratic formula if you want to. Now, everybody knows the quadratic formula works for everything. But I factored it by guessing and checking. And then your two possible answers were 3/4 and -1. -1 ended up being extraneous because, does anybody see why? If I plug -1 in right here, what do you get in the parentheses? -1. And you can't raise a negative to the 1/2 power because that's the same thing as taking the square root of a negative number. That is why -1 is extraneous. But when you plug 3/4 in, you see over there to the right in red why that works. So the only solution is 3/4 and -1 is extraneous. Okay, I'll give you a second to write that down. All right. Questions?